right, welcome back. So now we are going to do our day 2 of Unit 4, which is looking at inverses graphically. And now we are going to go ahead and do the classwork. And so what we're going to start now is we're actually going to go ahead and we're going to graph a function, and then we're going to go ahead and then graph its inverse and kind of see if there is some type of pattern to make it do this fairly easily. So it says, what is the inverse like when I graph it and when I look at the table? So here we have, it says, fill in the table and graph y equals 1/4 x minus 1. All right, so you have two ways that you can do this. You can go out to your graphing calculator and click the y equals button and type this in. I will recommend if you do type it in, you are going to want to type it in when you're in the little y equals button. You would type it in with parentheses whenever you have a fraction, 1 divided by 4. Then you would do your x and minus 1. You could go ahead, then you can hit graph if you'd like to see it. But then if you do your second graph button, so second key, and then graph, you want to go because you're going to be in the table. And you could go ahead here then and be able to find the numbers that you would do that. I'm going to go ahead and do it by hand because that's what math people do. Plus, you can't see my graphing calculator. So what this means is I'm going to go up here and I'm going to go ahead and calculate when x is going to be a -4. So I'm going to do 1/4 times the -4 right here from the table, and then minus 1. Well, if I do this, I get -4/4 minus 1. This goes to a -1, and -1 minus -1 is -2. Then I'm going to go ahead and do it again. Only this time now I'm going to get the next number that was in the table. That was a 0, so I'm going to put a 0 right there. So 1/4 times 0 is 0 minus 1, and I'm going to get a -1. And that's going to go right there. Now I will do it a third time. Whoops. And let's see, my next value that I am supposed to use is this 4 right here. So I'm going to plug in my 4, right? I put that there. So that would give me 4 times 4 minus 1. 1 minus, that would simplify to a 1. And 1 minus 1 is now 0. So I'm going to get a 0 right here. And let's go ahead and do that. So now let me erase again. And so then my last number from the chart that I haven't done that right yet, here is my 8. Oops, is my 8. So I'll put my 8 in right there. So 1/4 times 8 is 8/4 minus 1. 8 divided by 4 is 2. 2 minus 1 is 1. And so there's my value there. So I'm going to just go ahead and clean that up. And I'll also erase that, and let's get rid of that. Okay, so now I have my table. So we're going to go ahead and plot. So that means this, the graph of this equation is going to be in blue. So really what you have here, you have an ordered pair. You really have the ordered pair -4, -2. Remember, this is your x and this is your y. So we're going to go out over here. Remember, this is your x and this is your y. So right here is 0, 0. So since x is supposed to be -4, I'm going to go over here 1, 2, 3, 4. And then I have to go down on the y to a -2. So it looks like it's right here. Whoops. Sorry, my point is a little bit off. I'm going to go ahead and make this a little bit bigger so I can see these a little bit better. So I'm going to go over to 4 and I'm going to go down 2. So over to 4, down 2, I think it's about right there. Yep, I did pretty good. So there's my first point. Then I'm going to go get my next point, which is right here. This would be a 0 and a -1. So I go to, on the x, right? I'm going to go to 0, and then I'm going to go down on -1, and I'm going to put my point right there. Okay, then next, we'll do the next one, which was 4, 0. So I'm going to go out to x at 4, and then the y is 0. So we're just going to go ahead and stay right there on the x-axis. And then lastly, it was 8, 1. So now I'm going to go all the way over to 8. So 5, 6, 7, 8. And then I'm going to go up 1 on the y and put that there. And I'm going to go ahead and try to draw this as best I can. I don't think I can draw lines on here, so I'm just going to go ahead and connect them. And there it is. And I'm going to go ahead and actually label this and tell you that this is my y function. It's in blue. Okay. All right, so now we've graphed that. And now it wants us, it says in B, to find the equation of the inverse function. I'll switch colors so this doesn't get too crazy. So remember, to find the inverse, if my original equation is this, the first thing we're going to do is to change any f of x to y. It is already y. So we can go ahead. Step 2 is to switch x and y. So this is going to be x equals 1/4 y minus 1. Okay, so the first thing we're going to do then is we're going to add that 1 to both sides. And we're going to end up with x plus 1 equals 1/4 y. We need to go ahead and get rid of the 1/4. So let's go ahead then. And since we can go ahead and multiply by 4/1 or just a 4, that's going to cancel everything. So I'm going to go over here and multiply that by 4. So now we're going to end up with, let's go back to our green. We're going to end up with 4 times the quantity, x plus 1 equals, and all you had left was y. We didn't start with function notation, so you can just go ahead and put a little -1 on there. And so that way you know that that is the inverse of y. And so that is our new function here. Because it wants us to go ahead and fill in the table, even though you could leave this, it's going to be a little bit easier when I plug in these numbers to actually distribute this. So we're really going to say that this is 4x plus 4, right? Because 4 times x is 4x, and 4 times 1 is 4. And now that is my inverse equation that I am going to use. Okay. Again, you are welcome because we're going to fill in this chart. If you'd like to go ahead and plug that into your y equals in your graphing calculator and go to second graph and look at the table and find all of these x values and then go ahead and look to see what the y values are, you are welcome to. Again, I'm going to quickly do it by hand. So I'm going to go ahead and start here and I'm going to use my new inverse function. So I'm going to use 4 times a -2 plus 4 then is going to equal my y value. So I'm going to get here, I'm going to get a -8 plus 4, and that's going to give me a -4. So that means right here, that is my -4. All right, so I'm going to go ahead and do that again, except this time we'll go ahead and we will plug in the next value, which is the -1. So I'll put that right there. 4 times -1 is -4. -4 plus 4 is 0. So that means a 0 goes right there. Let's do the next one. All right, so now we have a 0, so I'll put a 0 in there. 4 times 0 is 0. 0 plus 4 is 4, so a 4 goes right there. Let's do our next number. Our next number was a positive 1. So we'll put our positive 1 right there. 4 times 1 is 4. 4 plus 4 is 8. So we're going to get an 8 right there. So that is our chart filled out if you did it by hand. I'll go ahead and erase those zeros. And I'll get rid of this just to keep it clean. All right, so now what we knew is we filled in the table and then it asked us to graph it. This one you're going to see here, I'm going to be doing it in green. Okay, so that you can see it on here. So again, we're going to go plot these points from the chart right here. So our first point here is going to be a -2, -4. That little thing is there. Let's get rid of that. Okay, so I'm going to go out on the x-axis. I'm going to go out to -2, and then I'm going to go down to -4. So 1, 2, 3, 4. I think it's like about right there. And then our next one from the table is going to be -1, 0. So I'm going to go to the x at -1, and I'm going to stay there because it said y was 0. Then our next one is 0, 4. So that means now on the x-axis, I don't go left or right. I stay at 0, but y is 4, and it's positive. So I'm going to go up 4 on the y-axis and put that there. Then our last one was 1, 8. So you go over on the x-axis to +1, and we're going to go up 8. That was 4, 5, 6, 7, 8. And I'm going to go ahead and put that there. I've plotted my 4 points, so I'm going to do the best I can right now to go ahead and connect them in a straight line. And there we have that. And I'm also going to label that. That was my inverse graph. Okay. So there they are. There's our 2 graphs. And it says, this is important. First, what do you notice about the table of the function and the table of the inverse function? Notice here, and let me change this to red. Well, actually, we'll change this to red. Okay, so look here, our first point was -4, -2. If you go here, look at this. This was -2, -4. This was 0, -1. This was -1, 0. And you'll notice the same things what's happening here. What do you notice? What you notice is, and I'm going to go ahead and type it in because it'll be a little easier, the values of X and Y are switched. Ooh, we were already switching the X and Y we were solving. And so look what happens to the table of values. The X and Y switch. Also, do you notice anything about their graphs? And I'm actually going to go ahead and draw this in. If we took a piece of paper, and again, mine's just a tiny little bit off because of using the technology, but if I took a piece of paper and I folded it right here, you'll notice if I folded it on that paper, the two graphs would actually smash and line up on top of each other. And so that means they are, and let's go ahead and let me go ahead and get my text. That means right here, and I'm going to type this one in blue, I'm going to go ahead and tell you that and we'll do this again, the graphs are, let's see here, symmetric. You can't see that. Let me go ahead and make this a little bit, yeah, there we go. Are symmetric over the line y equals x. That was the red line that I just drew. And we will come back to that towards the end. So let's go ahead and practice this. Okay, so there you go. There's that. So what I would like, what we're going to do right now, I would like you to go ahead and pause the video. And I would like you to go ahead and do 2A, which is basically what we just did. You can go here and notice I have already put in for you all of the X values. So you can go ahead and write those in on your paper. Then I need you to find the Y's. You can either try to find it from the graph. Notice we've already plotted that. So let me go and make sure that we realize that this graph here, okay, is the black one, and this is our Y. So you could either look there and find them. You could go ahead and plug these numbers in here and then do the math and get the answers. You could also put this in your graphing calculator in the Y equals, and then go to the table, look up these X values, and then write in the Y's. Okay, once you do that, then I want you to go ahead and fill in this table, learning what we just learned, what happens up here. What can you do to quickly fill in this table? All right, then once you have it, please go and plot this. So again, pause the video and do that work. And then when you come back, you're going to check your answers. You'll see me doing the work, but I am not going to talk. Okay, there are the answers. And hopefully you also notice when I went here, I took all of the X values and I switched them and I put them all over here in the Y's. And then I took all the Y values, I put them in the X, I plotted them. And again, you can also see, and I'll draw it the best I can, that these, if you folded your paper right here, that is the line Y equals X, that is symmetric, and they would line up on each other. Okay, so that was a line. Now what I would like us to do, we're going to do another function because we've been working with lines. Let's go ahead now and let's do a quadratic. Let's do a parabola. All right, so we're going to go ahead and do this one. And just for the sake of time, because we already know how to fill out these tables, these were the Y values that I'm going to pick. And again, I'll try to stay black with this one because it's already graphed for us. The Y values that we've just chosen, we just tried to make them easy. Usually you do like a negative number, a 0, a positive number. And because we had like one more here, I'll just go ahead and put the 2. So I chose -1, 0, and 1. I thought those would be the easiest. Again, you can plug these numbers in. You can go put it in the graphing calculator and see what the y values are that come out. But again, for the sake of time, if I plug in a -1, a y value will come out. If I plug in a 0, a 2 will come out. If I plug in a 1, a 2 will come out. And if I plug in a 2, a 6 will come out, right? Just to make sure you see that, it would be 2 squared plus 2. 2 squared is a 4 plus 2 and would give you 6. So we went ahead and we plotted those. So there are arrows here. And we know that is our y function. Now let's go ahead and do the inverse. Again, it's supposed to be pretty quick. Again, I'll make it green. So that means my inverse over here is going to go ahead and do the green. And so I'm going to go ahead and take all of the x values, because remember, when you go to the inverse, we switch the x and y's. So all the x values become the y values in the same exact order. You just write them. We're not switching signs or anything. You literally just take all the x's and write them in the y. And now I'm going to take all of the y's from the original function. And for the inverse, I'm just going to now write them in the x column. And there we go. And so now we can go ahead and plot these. So I'm going to do 3, -1. So 3, -1. Now I'm going to go to 0 right here. And then I'm going to go ahead and do 2, 1. So 2, whoops. Yep, is that 2? Oops, sorry. I made a mistake. Sorry about that. When I plugged the 1 value in here, this should have been, this is my fault. This should have been right here. This should have been a 3. Sorry, I'm not going to go back and re-record because this takes a while. So this really should have been a 3 right there. So now we're going to go ahead and we're going to go ahead and plot that. So that's 3, 1, 1, 2, 3. And then the last one was 6, 2. So 2, 3, 4, 5, 6, and go up. So 2, oops, sorry, that's my fault. Yep, sorry, 6. Wait, 1, 2, 3, 4, 5, 6, and go up 1, 2. There we go. All right, so that looks a little bit weird, but what was really happening now when I draw these in, this is what it looks like. It's going to go like this, and it's going to go like that. And if you see that, it looks like it is a parabola on its side. Okay, that's okay. Let's go ahead here and let's look at that. And again, I want to show you that we do have a line of symmetry at y equals x. If you folded your paper right here, I was hoping I picked up the red. If we had folded our paper right here and we smash those together, you can see that those are going to line up. And so we can tell that they are inverses. And we know, so just to label it, just to be good, we said that was the y, and then this is the inverse of y. All right, go ahead now and do, if you could do the one right below it. So we would like you here to go ahead and use this. I want you to fill in the table over here. You can see again that this is already graphed for us. I already also gave you x values. So however, if you want to plug those in or you want to go into the y equals and graph this and then see what the y values are for those x, go ahead. But I would ask you to pause right now. Do this on your own, fill out the inverse table, go ahead and graph, and then go ahead and start the video again. And I'll go ahead and work and not say anything. All right, you can go ahead then and see here. You can see that I've graphed that. Here we have it here. I know it looks a little bit crazy, but you can see again we had a parabola, and then for our inverse, it looks like a parabola on its side. Also, even though it's a little harder to see, again, if I go here and I draw that line of symmetry, y equals x, it's harder to see, but if you did try to fold it up, you could see like that these points right here, maybe I'll kind of highlight those, they kind of right here and right here, if we fold it along this red line, they would actually match up. All right, so there's that. Now, what we'd like us to do is, notice we just did the graphs. We didn't do any of the equations. We just did tables and graphs. But we do want to make sure that we know how to do all of these. And so this is our last thing that we are going to do well, almost the last thing we're going to do today. I'm going to summarize one thing, and then we'll be finished here. Okay. So let's go here and let's just write the inverse equations of these graphs, because we didn't do that. We just had the tables. I'm going to go ahead right now, and I'm going to go ahead and do the second one, and then I would ask you to do 1 and 3. So let's do the second one. So remember, our first step is we would change function notation to y. We already did that. So the very first step to get the inverse is you have to switch the x and y's. So this is going to be x equals y squared plus 2. And we're going to go ahead and we're going to start solving that. So we're going to say subtract 2. I'll draw it up here because I'm running out of room. So x minus 2 equals y squared. Then remember, to get rid of the square, to undo it, we take, I was hoping that was red. We take the square root, so those cancel. So 2 things to remember on this side. This is where I made the mistake in the earlier video. You need to make sure, one, that you make sure that the radical goes over everything that's there. And if you draw the square root, when it's squared, you must put that plus or minus on the front, please. Okay? And so then when you go do that, we now have what's left, plus or minus the square root of x minus 2. Again, make sure that bar is all the way over the 2, equals, that canceled, you have y. Now we need to write our function notation. Notice we started at y, so I can just go here and put the little -1 and we are finished. Okay, so now I'd ask you to pause the video and go ahead and try this for 1 and 3, and then come back here and check your answers. All right, so I'm going to talk through this one just in case, because there's kind of a lot going on here. So we need to get rid of all of these things. Again, remember your PEMDAS. We want to go in reverse order. So we're looking for any add or subtract that is not in parentheses. I have one right here with the 6. So I'm going to go ahead and add 6 to both sides first. So now I have x plus 6 equals 3 times the quantity y plus 2 squared. So now we did, we do have another add or subtract, but it's in the parentheses, so we're going to wait. So then we go up this chain, and now I'm looking to see if there's any multiply or divide that I'm doing outside the parentheses, and I am multiplying by a 3. So I'm going to go ahead now, and I am going to divide both sides by 3 to get rid of this 3. Again, make sure you, when you put your fraction bar here, that it goes over all the x plus 6, so that all of that is divided by 3. I'm going to go up here. So I have x plus 6 divided by 3 equals, now I have y plus 2 quantity squared. So I have to get rid of this plus 2 in the square, and I think you're pretty good at this. But again, looking now, if we're going backwards up PEMDAS to solve, the next thing would be E for exponents, and that's what we have. So we're going to go ahead and go here, and we're going to take that square root, and we're going to cancel that. So let's watch over here. We need to be careful. First of all, the square root symbol has to go over everything that was already there. Don't leave the little 3 out. Don't leave the little 6 out. And because we are doing the actual square root, you need to have that plus or minus in the front. All right. So now what we have is, let's look here and go and do our blue. So go ahead, we have our plus or minus the square root of all of this that's underneath there. And now it equals that canceled. You now have y plus 2 left. So now what we need to do is we need to go ahead and subtract 2 from both sides. This 2 is not part of this square root. So what's going to happen is when you write the answer, and I'm going to write it up here, I'm going to go ahead, since it's not part of that, I'm just going to write it first. So there's my minus 2. Then there's my plus or minus that was left. Then my square root of x plus 6 all over 3. All of that is in the square root equals, and let me erase this just because I need more room. And then lastly, that was gone. So you had your y. Now we have to write function notation. We did start with a y. So you're going to go ahead and put your -1, and there is your final answer. Okay. So I know that was a lot. So just make sure things are in the right place. Again, we will practice more on Monday. And then let's just kind of do this last thing here. It says when you look at the graph of a function and its inverse, you see that symmetrical relationship by a line of symmetry. So we already went back and we did this already. That was that red line that we drew here. So let's see, let me just remind you that if you have your coordinate plane, that line of symmetry that we drew that was red it always goes right through that origin right there. It is that kind of just slanted line or diagonal line. And it said, find the equation for each one. I already told you ahead of time, just so we had it. So we know that it is to get that red line. It is the equation y equals x. If you plotted this line, that is the line that you would get. Okay. All right. And so even though I kind of asked this last question, do you think this makes sense as a line of symmetry between the graphs? For a function and its inverse? And yes, it does, because we know that if this is the original equation, we want the inverse, it's this, which is going to be exactly the same. All the x's and y's are switched. All x's and y's are switched. And that's kind of that relationship between a function and its inverse, that we switch all the x and y's, whether it's in the function, the equation, whether it's in the table, and then when we're graphing. If you'd like to, there was one more thing here. This is optional. You do not have to do it, but I will go ahead and at least go ahead and graph this for you. So let me go ahead. Usually I would typically do the inverse first. And when you actually go and work this out, it would be 3 plus or minus the square root of x equals f inverse of x. And so basically, if you remember, I know here, there's a really kind of a quick way to graph this. I'm going to go ahead and graph the original one in black first. If we go back to without having to make a chart, we know with this square, this is a parabola. And we know if we have this 3 inside here, we know it's going to be shifted left or right. We also know it's the opposite. It looks like it's going to the left 3, but we really know it's going to the right 3. So that means it's just the parabola had been shifted from the origin over to the right 3, and it would look something like this. I'm just sketching it in. Now I'm going to do the same thing on the inverse, okay? So on the inverse, this is really our function. That was that square root function, and when it's positive, it should look something like that. Well, notice we have, so right now if it's positive, and then we have this 3 here, that means that we were shifted up 3. So maybe I'll rewrite it so you can kind of see it like this. This is really what it looks like. So if we do the positive of the square root function, we are moving it up 3 because this 3 is not inside the square root. So I'm going to go over here. I'm going to go up 3. I'm going to go ahead and plot it. And again, I'm just going to sketch it. And I know the square root function looks something like that. Then I have to go again now, and I have to do the negative. Remember, when something's negative, it's going to open down. We're still going to go to the same place. We still have shifted it up 3, but now it's opening down, and it's going to look like that. Sorry, this was not a great graph, but it is there. And I know I kind of kept using my red, so I'll just use my blue. And there actually is a line of symmetry. Whoops. There actually is a line of symmetry kind of right through there. If you folded it, you can kind of see here that like these would match up if we folded it along the blue dotted line, and they are symmetric. The last question, though, that I do want to mention, and we can talk about this again, they were asking us if the inverse, which again is your red graph that's up there, your red graph, is it a function? Why or why not? And remember back when we did this in that unit, if I go here and I draw, let's see what I'll use. Let's use this purple. If I go through on the red graph and I draw a vertical line, how many places does it hit the red graph? It hit it in 2 places. So is this whole entire red graph actually a function? No, because of the vertical line test. It's fine that it's not. It doesn't matter that the original thing that we started with was a function and now its inverse is not. That's okay. But it is not. It is a vertical line test. And that's also then why we have the plus or minus, because each one of the red lines is a function. But when we graph it together, the resulting graph is not. So that's it. Please go ahead and move on to your homework and have a great weekend.